So, good afternoon. First of all, thank you to Alexander Gordon for getting me here, for taking care of the thematic focus of this computer art festival. And thank you to Sonja Gregorn as well, who has taken administrative care so much, and for putting me at the Hostel Pekana, where there is hard rock music not only on Saturday night, but even on the Sunday afternoon, so it's an optimal preparation for a lecture.
Hard metal. Hard metal.
Yeah, it's death metal, definitely.
Death metal.
Yeah, and that's what I wanted to say. Luckily I like it, so I just felt very inspired. So I'm in a quite energetic mood. And I have to say that it's very gentle atmosphere in Maribor to perform. So, as an actor of cultural change, artificial intelligence has entered the scene of the media cultural theater. In artificial intelligence, or to be more precise, in machine learning, is this understandable as long as it is in progress? Can we, while it is developing every month, can we understand what is going on inside? According to Michel Foucault's classical book, Archaeology of Knowledge, one cannot understand the archive of the present, the secrets which are happening in the present, while one is living in this present. One can always understand it when it becomes past. So, can we be fast enough to understand the development of artificial intelligence while it happens, or only in retrospect? That's a crucial question. First of all, it's not only a question of the present artificial intelligence. Artificial intelligence has been induced already, I would say, for 2,500 years ago. Because the Greek modification of the Phoenician writing system into the elementary vocal alphabet which we use in writing, combined with the cultural technique of counting by discrete Arabic numbers, 1, 2, 3, 2, 4, the alphanumeric code, and finally algorithmic mathematical procedures, which we call computing, they have already not only extended human reasoning, but fundamentally redefined its performances in favor of abstract symbol operations. I would go so far, the fact that I give articulated speech to you is already an incorporation of an artificial intelligence in my body. So it's not that new or alien to us that we are using those symbolic systems. Concerning a periodization of machine learning, and this is one of the central topics of this festival, the cold winter, how it is called, of artificial intelligence, after an enthusiastic take-off in the 1980s, has been due to ideological dead ends of the cybernetic optimism and to the lack of computational power and big data. So in the first movement of artificial intelligence, the computers were not strong enough to develop their ideas. Now they actually are. Now we have those massive parallel processing computational devices, and now we have the big data available from which those computers can learn and process. So this is why artificial intelligence, in its second effort nowadays, is a so-called killing application and successful. Now, when I say artificial intelligence should be called machine learning, it's even called deep machine learning. And it's called deep machine learning, and there seem to be so-called emergent properties and irritating artifacts. And they seem to escape the conventional tools of analysis. What is happening in those deep layers? How do those figures of speech and images emerge? Is the choice of metaphysical terminology like emergency and deep learning, those are metaphysical terms, is this simply a semantic cultural lag against the accelerating speed of artificial intelligence? Or is this a symptom of a more fundamental challenge and epistemological irritation of the traditional mind-matter dichotomy? Are we still able to understand what is going on in AI? It was easy for the industrial age to know how an engine works, or even for the people who produce electronic music, how a synthesizer works. You learn a bit of circuitry and electric engineering. You know how the synthesizer produces this sound. But with artificial intelligence, it seems to be a much bigger challenge to be able to analyze what is going on inside. Now, the approach which I call media archaeology is not assuming ghosts in such machines, and rather tracks AI's technologos, how I call it, its own reasoning. Can that be traced? It radically insists on opening the black box of artificial intelligence in a non-anthropocentric approach by identifying the diagrammatic reasoning that intrinsically arises from within the techno-mathematical mechanism and circuitry itself. So this was mentioned yesterday in the lecture as well. It makes a difference whether we have the focus on how humans perceive what is going on, what effect does it have on human culture, or do we understand it from the point of view of technology itself, what is happening. AI and machine learning are not a simple escalation, but rather the finalization of classical computing. It's not just a further step, it's a paradigmatic shift which is going on. Is thereby even the period of computer art coming to an end? This is an issue of this festival as well. Is AI-produced art still part of the history of so-called media art or computer art? Or is it actually, is there something different emerging? Is there a new paradigm arising from artificial neural nets, which rather induce a renaissance of what used to be analog computing, even if they are still disguised in digital standard microelectronics? In the sphere of generative or synthetic text, sounds and images emanating from AI toys like ChatGPT or Stable Diffusion, should there be, for the sake of rigid analysis, instead of hardware centrism or critical code studies, a shift of emphasis, a focus on the techno-mathematical layers which are at work in between hard and software? For computer, we concentrated on discussing the electronics or the programming, the code. But the method, the power of AI now is the mathematical models, which is not easy to analyze for non-mathematicians. Now, a non-anthropocentric analysis of AI and machine learning stays consciously suspended or bracketed from the social or ethical concerns, at least for a moment. Now, I know this is a critical point. I say media archaeology does not immediately talk about the social impact of AI. That's what we learn, what we discuss every day, or we experience it every day. But as a knowledge object, and I think this is the task of academic analysis, in terms of what knowledge happens, we should bracket, in phenomenologist Edmund Husserl's sense, the question of the social consequences or the ethical consequences, because the discourse is all about that in AI. No, as a knowledge object, we should bracket this for a moment and rather investigate the technologics from within or among machines, because we should not forget, it's not about machines communicating with humans, AI. AI is mainly about machines communicating with machines, and to learn this different communication, I would not call this a social question anymore. Most apocalyptic expectations or messianic promises tend not to take sufficient account of the material element of AI technologies, which itself operates upon already informatized matter and energy. While Kate Crawford's book, very successful and important, Atlas of AI, Power Politics and the Planetary Costs of Artificial Intelligence. That's the title of the book. This book brings critical reflections on artificial intelligence back down to earth in terms of ecological issues, in the discourse analytical sense. Well, different from that, media archaeological analysis is literally grounding, to take a term from engineering, AI and machine learning in its concrete techno-mathematical materializations. It's realized in matter. That's important. It's realized in electronic matter. Such mechanizations are not simply derived applications, but primary conditions of AIs coming into existence, eliciting the implicit intelligence of technically informed matter and energy. To really intervene politically, one should also intervene in the design of the technologies themselves. Certain micro-political features may be already materially in hardware or logically in software incorporated in the current design of technologies. This sociocentric view of AI as tool, though in the tradition of French apparatus theory, is media archaeologically contrasted by identifying technological eigenintelligence, I would call it. Sometimes even English language uses this eigen word from physics, that escapes even the implicit ideological impulse. So I would say the knowledge of AI is more clever than the discussion of the bias of AI and of the data by which machines are trained. Cultural analysis and science and technology studies critically deal with the underlying ethics in machine learning, such as its gender or race bias that is inscribed already in the algorithms of the operational system and the data sets for the training of machine learning, which is certainly there. Radical media archaeology, on the other side, rather focuses on the epistemogenic momentum of such technological configurations themselves. The word bias, after all, is a term from electronic engineering, meaning the operating point, direct current, voltage or current about which the instantaneous value might vary. Radical media archaeology identifies such a bias within the artificial neural net itself, rather than in its external cultural discourse. But there is a sudden dialectical synthesis of technical analysis versus media sociology. Once big data derived from social media platforms are used for training AI to mimic human behavior patterns by sheer massive imitation. Machine learning is turning the term social media upside down, algorithmically transforming technically mediated telecommunication between humans into a big data source to be processed upon artificial neural nets. Composer Richard Wagner has become famous for a technical camouflage. In his design for a festival hall in Bayreuth, he introduced the orchestra pit to hide to the audience the visually disturbing, how he called it, disruption of showing the production of sound. When you sit in the audience, you don't see the orchestra anymore. That was Wagner's innovation in orchestra hall design. By hiding the orchestra in a deeper layer of the architectural ground, in an act of sublime dissimulation, Wagner actually reenacted ancient acousmatics and anticipated loudspeaker sound in electrified culture. Petra Kapsch knows what I'm talking about now, where the music seems to emerge like a sonic spectre and literally spectrally from a mythical abyss. Now, I compare this to our attitude to AI. We don't really see how those texts by ChatGPT or these images or artificial sounds, how are they produced? So we are concentrating on the screens where we see the final results. So that I compare to Wagner's trick. Against a similar metaphysics in the current discourse about machine learning, a dismantling and opening of the black box of its so-called deep layers is critically required. If we want to have a critical attitude to AI, we have to open this black box. And to achieve a sound understanding of so-called artificial intelligence, both in terms of neural net electronics and its underlying mathematics that departs from so far brain modeling in favor of a genuine technologos. It is true that historically what we call artificial intelligence and machine learning has been developed as a tool to understand or to model technically how the brain works. That's the neurocognitive science impetus. But since all AI is realized not in wetware like the human electrochemical brain and body, but in electronics and hardware, a different logic takes place. So we should get rid, and AI itself gets rid of this strict orientation to the comparison to the human brain. But where can that condition or possibility be located exactly? Should we look at the brute matter of AI machines on their hardware? Should we see what are the algorithms, what is the code in a language like Python or other where you program AI? Or should we look at the big data which are used for training the AI? So what is the black box which we have to open? That's the crucial question. On what level? While the cybernetic paradigm, which once started AI, even the term AI comes from the 1960s, while this stays with the black box, media archaeology resists a mere aesthetic metaphorization. To what degree is it possible to technologically infer from a comparative analysis of the input-output relation the essence and operativity of AI's black box? That would be the black box approach, to say we have input and output. What happens within the black box we are not really interested in. We compare input-output. That would be the social behaviorism approach. But for media archaeology it would be very important what happens inside. White box attacks, that's the opposite, where you open it, on layered convolutional neural nets, reveal their backpropagation errors. So only by attacking the black box within, you can produce what looks to humans like errors, and then understand the rationality or what looks irrational in machine processing. But the internal machine learning mechanism is not reducible to algorithms anymore. That would be classical computing, since its output generation, be it text, music or images, stems from the combination of software with big data and thereby results in unpredictable emergent phenomena. Artificial neural networks are still powered by huge mathematical differential equations, but unlike classical computing and statistics, a rather stochastic model replaces the logical approach. The stochastic is in mathematics the term for counting with probabilities, not with certainties anymore. When we think of digital computer, still there is this idea of either 0 or 1. Everything is done by dividing 0 and 1 and having logical programming. But the paradigm, the mathematical paradigm in AI is stochastics. You count with probabilities, with similarities of images, not by exact comparison. So the logical approach is replaced by, not even by a statistical, but by a stochastical approach. Even if most actual computations performed by artificial intelligence are not visible to the human user, rigid media philology looks for ways to make such algorithmic procedures transparent, both hard and software, and the operative, literally technological diagram in between. Is there something like a debugger for the errant data path decisions in convolutional, artificial,
neural nets, can we trace the single steps which happen in ultra-fast speed on multi-levels within the AI machine. In his keynote lecture to the 11th World Computer Congress in 1989, computer programmer Pope Donald E. Knuth challenged his audience by suggesting a thorough analysis of everything a computer does during 1 second of computation. So just imagine, slow down a computational process which goes on with electronic speed to all the single steps. Would that be a way for humans to still understand what is happening step by step? Can the technologies of AI in being, instead of reducing it to the protocol of symbolic program changes, be identified by slowing it down and maximize its elementary actions in archaic materialism as much as possible? Media artist Ralph Becker's light and sound installation Floating Codes at the Ars Electronica Festival last year in Linz explored the inner workings and hidden aesthetics of artificial neural networks by concretizing the fundamental building blocks of machine learning system in the form of 250 custom-made artificial neurons, which he displayed in the room. Their idiosyncrasies made it evident to the human observer, you could even walk between these neurons, that media artificial technologies is no derivation of the mind, but developing an alternative intelligence of its own. According to philosopher Leibniz's monadology, perception itself cannot be explained and therefore not be simulated by mechanics. Entering such a perceptron, one would perceive just moving elementary units, but they do not assemble to something which comes close to cognitive figure in human perception. Nowadays, though, artificial neural nets enact exactly such a mechanism. So while Leibniz still insisted perception is something which you cannot analyze by identifying its single elements, that would be a machine, but this is exactly done by machine learning nowadays. But for the system to achieve this, it still requires a translation of real-world signals, as it is well known from robotics via sensors and the analog to digital converter. It still requires a translation of the real into the symbolical regime to make it operative intelligence. Because everything which we call artificial intelligence coming out of machines has already translated real-world signals into symbols. It's still digital symbols. So we should be aware that here a translation from the real into the symbolical regime takes place. Computing hardware itself cannot self-reflect its own activities other than by emulating the mechanism that is transcending its concrete physical materiality by means of an abstract symbolic software model. For the analysis of phenomena which emerge, I put in quotation mark, in machine learning, a reduction to their sub-symbolic electronic steps, even below debugging and watching parallel signal processing in ultra-slow motion, provides a material sense of machine learning, but misses its essential complexity. So the more we would identify the single steps of AI processing, then we would still miss the essential stochastic complexity. So we cannot have both. We cannot look at the single element and identify the single steps and still see the complexity which emerges. There actually is software, but it unfolds in a new sense. Thus, its technologies reside in the dynamic diagram. Neurophysiologists like Ralph Gerard at the MEJI conference on cybernetics in New York in 1950 already anxiously worked to localize the digital within the real, while Claude Shannon in the same conference series for the analysis of a switching circuit, such as a telephone network or an artificial neural net, define the symbolic as the limiting value of the real. Now I'm here using terms which were developed by psychoanalysis in Jacques Lacan, who says the drama is how physical matter, the real, confronts the symbolical order, where we try to alphanumerically put it into a rational system, because they never converge. Whereas Norbert Wiener excluded the time of non-reality that occurs in between binary switching states, because there is 0 and 1, but what is in between? Every technology, there happens something between 0 and 1. Now this is ignored in binary computing, and artificial intelligence machine tries to calculate exactly with this in-between in flip-flop based electronics. AI now literally counts with intermediary adjustable weights, how they are called, with its computational mechanism approximating the analog domain of real numbers. Each numerical value within an artificial neural net is materialized not as sign, which exists only as arbitrary mapping or code, but as actual signal. This is a non-numerical operation of computing itself. That's why the notion of computing itself changes with machine learning. And it has been frequently reminded from the side of media ecology, there is a very material condition behind the apparently virtual cloud in the big data web. Rare earth mining, energy consumption of Google server farms, etc. But in the case of artificial neural nets, this material infrastructure is no longer simply a passive channel for transmission of messages or datagrams, but becomes active matter, to use a word-developed concept by my colleague Wolfgang Schäffner at Hamburg University. Matter itself becomes active. Matter is not used to impose a digital logic on it, but you calculate with matter itself. That's something which quantum computing tries to achieve as well. This is a dramatic shift in use of on the concept of technology. Artificial neural net configurations are logifications and sophistications of the web, inducing the serendipity of technologies to come out and express itself. Now actually, before I forget that, we should show my very short video, which I was meant to show you in the beginning, but I was talking too much. Look at this image. In our signal laboratory at Hamburg University, we installed Stable Diffusion on a computer server, but the Acre computer, where we installed the local AI, has this interface of a pulsating assets. Huh? That is exactly the image which not only which computing industry and AI industry wants to give us. That there is something almost organically or intelligent going on, as if it was lifelike, and this dissimulates the calculation operation which actually take place. It is meant to look like a living being, pulsating, and it dissimulates the radical techno-mathematical essence which goes on. Okay, we'll let it run in the background. Because it's exactly this metaphysical notion which has to be criticized and opened. Quantum physicist Karen Barrett directs attention to what she calls the agency of matter itself, and how we can interact, not interact, interact with matter in an entangled dialogue. So our relation to technology changes. Technology is not something outside the human body anymore, but our interaction is involved in the matter of technology itself, and we are discovered as being technological ourselves. Now, this is a challenge to human narcissism. Some kind of implicit material intelligence of agency might be activated, so that matter can perform itself, how Karen Barrett expressed it. But Technologos operates not in brute physics, already, but only from technologically informed matter. It's not that the stone itself can express intelligence, but if you use stone or sand or a crystal like silicon, and you count with silicon itself, then you have informed matter, and then matter can show and become expressive in an intelligent way. Artificial neural nets are still rather isolated media epistemic playgrounds or philosophical toys that invite for experimenting and experiencing the new kind of machine intelligence in and as signal processing. Most AI and machine learning applications are still trained by the symbolical machine, which require digitized big data with labels and words and metadata. The real world of continuous signals escapes such computation, even if computing by digital signal processing has been extended to an appropriation or approximation of real physics. The information machine still processes binary signals, ignoring matter or energy by definition, such as idiosynchronous human flash or alternative electronic hardware. According to the theoretical inventor of the digital computer, Alan Turing, the machine-like parts of human reasoning may as well be enacted by a symbol manipulating machine. Turing simply stated, when we are calculating on paper, adding numbers, we are in a machine state. We are computer already when we operate with discrete symbols. So we are getting away from this clear divide. There is human body on the one hand and mind, and there is machine on the other hand. We are, as minds, to 50% in machine states ourselves. To what extent do digital algorithms partake of the extended software-like nature of the mind? Once thought is considered as a syntax that can be programmed and can run on any human or digital object. In the cybernetic Turing machine perspective, the mind and the algorithm are not categorically separated at all, but systemic symbol processing embraces both regimes. So we are not that different from computer. When we are doing reason, when we are operating reasonable thoughts in our minds, this is already computing. That's the radical thesis, how Turing, who actually invented the Turing machine, conceived the relation between technology and human mind. And this now extends to DNA code approach to life itself. The writing machine, such as a word processor, no longer simply co-determines human thought, as it has been expressed by philosopher Friedrich Nietzsche. He is well known for having been the philosopher in the 19th century to use a new medium, the typewriter. Nietzsche was one of the first philosophers to use a typewriter. And then he wrote this famous sentence, well, when I'm using the typewriter is co-producer of my thoughts. But now we are one step further, because with AI and machine learning, the machine or the typewriter is able to write itself. That's radicalization which happens. You might actually wonder, or I asked myself, preparing this afternoon, because you see I have a paper here. Do you know whether this is my text or whether this was produced by ChatGPT? What I did is, what they're having with the death metal in the background, I scribbled into the text, because I tried to understand my own text when I prepared it again this afternoon. Now, as if I was irritated for a moment, is my mind an artificial intelligence which has written my text? And that's exactly the attitude which we might come into. Get away from this clear distinction between human mind and technology on the other hand, and open ourselves to the idea that we are artificial intelligence already. It's not a question of human intelligence versus artificial intelligence, but intelligence itself is already a mechanic operation, which happens when, for example, I think combined with the keyboard of a computer and I write a text. I'm in a machine state then. So I follow Turing in this argument with my own experience. Is the artificial, in so-called artificial intelligence, the Latin word ars, or the Greek word techne, is this still just an objectivation of the mind, as philosopher Hegel would call it? When the intellect becomes machine language, the essence of its articulation is ephemeral, that is a temporalization of the mind. As such, it becomes a form of epistemic experimentation, which derives its appeal from its differences to neurobiological embodiments of the mind. We can think, but when we use a computer or an AI toy, it's the mind experimenting with itself. And our mind can only become aware of itself when it becomes exteriorized and becomes a toy for experimenting itself. That's why AI is not a difference from human intelligence, but rather a way of human intelligence experiencing itself, or experimenting, playing with itself. It's like a laboratory. And that results in a kind of what Ian Bogost in his book calls an alien phenomenology. Our mind wants to see itself objectified in order to become aware of itself. So it's an epistemic toy. This kind of objectivation as becoming other technologically discontinues Hegel's phenomenology of mind. Whereas for Hegel, there is the mind which becomes exteriorized, for example, in language. When I speak, this is already an exteriorization. The voice is already an exteriorization of the mind. The AI approach would say, epistemologically, that actually the mind is experiencing itself. That's a different attitude. It's a more positive way of enacted intelligence. Machine learning will actually relieve humans from a couple of intelligence functions in favor of focusing on rather unexpected idiosyncrasies, just like photography once relieved portrait painting from the pressure of being realistic in favor of more experimental avant-garde experiments of representing the human face. So what I say here is, the more there is artificial intelligence, and it can take over intelligence functions from the human becomes in a way liberated to discover other things of being human. So it's not a threat to human intelligence, because with every new technology, parts of the human, like the body by the machine, have been substituted, but this did not result in the end of humanity. But humans started to focus on other things then. And I think a similar thing will happen now with AI. So, in the end, on the one hand, artificial intelligence is a challenge to a technocentric approach, but at the other hand, it invites to dismiss the anthropocentric perspective. Because most of discussion of AI is so much concentrated on how humans perceive it. Whether the neuron itself is the proper level of a functional analysis of machine learning is still an open question. And that's why I brought an artificial neuron here. And I don't show it as an image, but we can even circulate it around. As you will soon identify, this is from one of the earliest digital electronic computers, and it has its condensers and resistors, and the main element is this vacuum tube, which is a doubly integrated triode, and this is a binary switch. By this you can keep electricity in a 0 or 1 state. Now this was used to simulate human brain, because when it was discovered that our brain functions like that, the neurons in our brain are either activated or not activated. So this invited for saying, well, it works like a computer. It operates in 0 and 1 stations. So the first artificial nets were built with this flip-flops, and but why did I bring it here? Because you immediately see this is a completely different thing than the chemical neuron which we have in our wetware called brain. And since this is electronics, it serves as a metaphor for the human mind, but at the same time it insists and articulates, I'm following a different logic, I'm a different matter, and that's why I develop a different kind of intelligence when I combined an electronic system. So let us not confuse the idea of modeling the human brain by neglecting the matter by which it is modeled, because the model itself develops a logic of its own, which is different from the human brain. So that's why John von Neumann and others from the beginning warned again that we should not confuse a computer model of intelligence with the working of the human brain. And the tragedy is that the questions originally came from cognitive science, from neuroscience. So we read artificial intelligence always back to the question, how far is it able to emulate the human mind or human creativity? And we ignore the fact that it develops a logic of its own, and it becomes more interesting when we let technology develop its own logics and get away from this comparison with the human mind. That's why we need to liberate the discourse. And that's why I brought this material, artificial neuron. Now I see time proceeds, so I come to slightly more visual end, and I jump a bit here, and we come into the question of how is the relation of artificial intelligence to images, to make it a bit more concrete. After I have said so far artificial intelligence and machine learning should not be regarded as a tool in the instrumental sense, and now even companies and lawyers, more and more in our everyday life, artificial intelligence becomes simply a tool to be applied, even in the arts. But if we see it as an epistemogenic toy, as a knowledge generating toy, then it has a different value. Actually, it's structurally equivalent to music, which is no direct externalization of inner subjectivity, but it's objectified diagram. And electronic circuitry, different from the neural brain itself, allows for experimentation in a controlled way and lets technologies to be co-articulated. Now, to come to the visual end, it's combined to the question, what is the creativity of machine learning? While programmers still set some parameters, even in machine learning, a machine learning artwork itself is actually generated by the artificial neural network itself in a process which is considered by many to be similar to the thinking process of human beings. But one of the most famous images which were produced by the generative adversarial neural nets, where neural nets correct themselves and by that learn to produce images. One of those first artworks which were accepted by the art market and sold at Christie's in London famously has been produced by the art collective Obvious, the famous portrait of Edmond de Bellamy, at which we could have a quick look to. I'm sure most of you know this. That would be, yeah, this is the famous. Now, this was by using from image banks a lot of portraits of a British 18th century, an adversarial neural net produced this portrait, which was then accepted as one of the first genuinely accepted by the art market portraits of AI and sold for a lot of money. Why do I show you this again? It's interesting that the art collective called Obvious signed it like this. Look at this, and now we can look at the next picture. I enlarged this part. Now, the signature of the portrait is not the artist anymore, and it's not even the artistic programmer or the programmers, but it's one of the core mathematical formulas which process this massive training by 18th century portraits. So a mathematical formula replaces what used to be individual or collective artistic subjectivity. And now we can even show the next image. This is just one of the formulas. We see it becomes a bit more complicated when we see step by step what entropy and other mathematical formulas are actually used to produce such an artwork, for example, for character recognition in handwriting. So we see the human agency has been replaced by techno-mathematical creativity, and the artist group has been honest enough to display this mathematical formula. Now this is a challenge to the art world and to humanities and to philosophers to a large degree, because there is no way of not confront the mathematical if we want to be critical. And if we want to be political, we have to understand mathematics as well. That's not easy, because I was not trained as a mathematician and in media theory. Now I know there is no way to open the black box of AI. Has to get acquainted to this mathematical intelligence which is applied, and which is applied because a formula cannot do anything by itself. It has to be embodied in electronics in order to become operative. So we even have to see this mathematics and the way how mathematics affects matter. That would be the way to critically open the black box of AI and to experiment in the signal laboratory. And by that, I think for the moment I could even make a stop and wait for discussion, because it would be too much even now to finally come to the imaginary in the Lacan sense. Maybe just I read to you my last sentences. That true machine learning, with an emphasis on the machine, should not be biased by the human brain model anymore. What I am pleading for is to liberate artificial intelligence from its anthropocentric concentration. Can it simulate the human mind? And to liberate it from this towards a possibility to let artificial intelligence develop its own articulations, to which the glitches of AI are a wonderful hint. Although the AI industry tries to eliminate all the errors which are still there when the eyes are not correct in images produced by AI, for example, or we discussed it on your big poster, which is at Maribor. There's this double teeth row in where we can see there are still errors. And industry and AI developers try to get away from these errors. But the errors, we should make them strong to see how that the technology itself has its own logics. It's a different aesthetics, it's a different logics. And it's more exciting to let this, to enhance it. Because then humans learn something non-human. And that would be interesting in terms of generating new knowledge. So that would, this plea for liberating AI from the human intelligence comparison would be a critical and productive, I hope, answer to making use of this chance. Okay, I stop at that moment. Thank you for your attention, and now I wait for your protest.
Thank you for now.
Okay.
Maybe we should